Increasing and decreasing interval of functions. I am Anil Kumar, and in this video we will explore a derivative of a function to find the intervals of increase and decrease. Question is, for a particular function, derivative of the function is x squared minus 2x cubed. Determine the values of x at which the derivative is 0. Find the interval of increase and decrease for the function. How do you know from the derivative of the function that there are two turning points for the function? So let's answer them one by one. F prime x, that means derivative of the function, is x squared minus 2x cubed. So we could factor this. So if you factor x squared, you get 1 minus 2x. Right? So that is the factored form. Now let's answer part A. Determine the values of x at which derivative is 0. That means f prime x is 0. Now x squared times 1 minus 2x is equals to 0 gives us two values. One is at x equals to 0. The other one is at x equals to half. Right? So these are two values. How do you get them? Equate each to 0 to get your zeros. Right? So that is how you get them. Part B is find the interval of increase and decrease for the function. Now these are the places which are the turning points. So these are turning points of function, right? On graph of function. Now either side it will be increasing or decreasing. So we can test it out. So to test, let us take the points on a number line. We have zeros which are at 0 and at half, right? So half, 1 over 2. Test point on the left side of 0 could be minus 1. On the right side we can take 1 over 4, right? Or 0.1, let's say 1 over 4. And beyond half we can take 1 as our test point. We are trying to find the sign of derivative of x, right? Not the real value, just a sign. Now if I substitute minus 1 in this formula, what do I get? Minus 1 will make this positive, but this will become also positive, right? So you get a positive value. So f prime for minus 1 is greater than 0, so it is positive. Since it is positive, on the left side of 0 we'll get the function as increasing, since the tangent is positive, slope of the tangent is positive. If I substitute a value which is 1 over 4, in that case x squared will always be positive, correct? This is always positive. Here if I write 1 over 4, then 1 minus 1 over 4 of so 1 minus 1 over 4 of 2, that means 1 minus half, so that is going to be positive again. So for 1 over 4, if you calculate the value f1 over 4, what do you get? You again get a positive value. So this is also greater than 0. Since it is greater than 0, in this interval also we get the function is increasing. Now if I check the value at 1, that is the derivative at 1, in that case if I substitute 1 here, x squared is going to be positive. However, this will be 1 minus 2, a negative value. So we are going to get less than 0. So in this interval, the derivative is negative, and therefore tangent will be going down, right? Negative, and the function will be decreasing. Okay? So from here, what we can say is that the function actually is, the increasing interval for the function is from minus infinity to 0, and then from 0 to half, right? So interval of increase is, let us say, interval of increase is from minus infinity to 0, and then from 0 to half, correct? That is the interval of increase. Since the derivative in that region is positive, right? On the other hand, interval of decrease will be from half to infinity, right? So from half to x value of half to infinity. So during that period, the function will be decreasing, correct? So that is how the derivative gives you result of interval of increasing and decreasing. Well, you could also kind of sketch this function and get a similar result. So we have derivative as x squared times 1 minus 2x, right? So this is leading coefficient is negative, so right side is down, and the derivative here is linear, right? This one is linear, so it will cross this graph here, the derivative, and it is going to turn here, right? So it is kind of going like this. The graph will be kind of like this. It bounces back from here, and then it will be kind of like this. So that is the graph for the derivative of the function, right? So you can see derivative is positive on either side of this turning point, right? But it is negative after that. Do you see that? So that is how the derivative acts, correct? Okay. Now let's answer the part C, which says, how do you know from the derivative of the function that there are two turning points for f of x? Now that is known since we have two zeros of the derivatives, right? So derivative is f dash x is 0 at 2 points, at x equals to 0 and at x equals to half, right? So both result because of turning points on the graph of function, right? So the function will be of degree 4 and it will have turning points at both these points, right? That is how we could answer this kind of question. I hope that is clear. Thank you and all the best.